Tesla has officially purchased a new Giga Press machine that will allow it to build the entire underbody of its affordable car, the Tesla Model Q. Here's what Elon Musk had to say about the madness of the machine.
Like real fast. And then I guess maybe we need to just get even bigger casting machines. Sure, why not? Down, yeah, let's 50,000 tons.
A massive die casting machine the size of a house, capable of producing a new Tesla every 5 seconds. Sounds like science fiction? It's not. This is the new version of the Giga Press, something Elon Musk described as a giant version of a toy factory, but with power that far exceeds imagination. This machine doesn't just cast one part at a time. It can mold 5 vehicle underbodies simultaneously. Tesla is the first electric vehicle manufacturer in the world to apply gigacasting technology to mass production. While many competitors are still struggling with traditional assembly lines, Tesla has taken a giant leap by integrating GigaPress machines into its smart manufacturing system, and it keeps improving. It all started with the 6,000-ton GigaPress used for the Model Y, which replaced over 70 separate parts with a single aluminum piece in one shot, cutting production time, lowering costs, and boosting precision. Then came the 9,000-ton GigaPress, powerful enough to form the underbody of the Cybertruck, one of the most advanced chassis in the EV world. But Tesla's ambition doesn't stop there. The upcoming 50,000-ton GigaPress is set to achieve something no previous GigaPress has ever done. So why is such an enormous pressing force necessary, and how can a single machine produce 5 vehicle frames at the same time? Let's dive in and find out. Welcome to Tesla Car World. Before we get into the cutting-edge EV manufacturing tech, let's go back to the beginning, to where the concept of the Giga Press was born. This isn't your average machine. The Giga Press is a high-pressure die-casting machine developed by Italian company Idra, which is now part of the LK Machinery Group. Few people know that this revolutionary idea actually began with a simple, everyday moment. Elon Musk, while holding a die-cast toy car at his desk, suddenly asked himself, why can't we do the same with real cars? What started as a seemingly wild question led Musk to envision an entirely new direction for the auto industry. Instead of assembling hundreds of stamped steel parts using welding robots, why not cast the entire car underbody as a single solid piece of aluminum? At the time, Tesla was struggling with pressure to ramp up production of the Model Y, the company's best-selling vehicle. The challenge was to speed up manufacturing while cutting costs. The Giga Press became the strategic solution. According to many industry estimates, replacing a traditional multi-part underbody structure with a single cast piece has cut production costs by 20% to 40% per vehicle frame. But the road to turning this bold idea into reality was far from smooth. Elon Musk reached out to the 6 largest die-casting machine manufacturers in the world to request the creation of a massive high-pressure casting machine. The result? 5 companies said no. They dismissed the idea as crazy, unrealistic, and far beyond the technical standards of the automotive industry at the time. In the end, only one company was willing to take the risk, Idra. Even then, they weren't entirely confident. At first, everything was just a maybe. But after nearly a year of collaboration with Tesla, Idra succeeded in building the world's first Giga Press. As we mentioned earlier, Giga Press machines are now used to manufacture large vehicle components, especially the underbodies of models like the Model Y and the Cybertruck, using forces of 6,100 tons and 9,200 tons, respectively. The operating principle of the Giga Press starts with melting an aluminum alloy at extremely high temperatures in a furnace. The molten aluminum is then injected into a metal mold, shaped like the component being produced, for example, a car's underbody frame. The Giga Press applies extremely high pressure to ensure the molten aluminum fills every tiny detail of the mold perfectly, leaving no defects. Once cast, the part is evenly cooled, causing the aluminum alloy to solidify into its final shape. This process requires extreme precision. If it's too fast, air bubbles can form. If too slow, the aluminum may start to cool before the mold is fully filled. Cooling is carefully controlled through a uniform cooling system, helping the final part achieve high strength and dimensional accuracy. After cooling, a robot removes the part from the mold, trims any excess material, and sends it through a quality inspection process. It may sound complex, but in reality, the entire process happens incredibly fast. The advantages of vehicle frames cast by the Giga Press are significant. By casting a single large piece instead of welding together dozens of smaller parts, Tesla reduces overall vehicle weight, increases structural rigidity, and boosts performance, all while saving time and labor on the production line. Beyond Tesla, other automakers like General Motors, Hyundai, Volvo, Zeekr, and XPeng have also invested in this cutting-edge technology. Notably, XPeng has committed to a massive 16,000-ton Giga Press. However, Tesla remains the first, and so far the only company, bold enough to push the limits with a 50,000-ton Giga Press. Why does Tesla need a 50,000-ton Giga Press? Producing the Model Y's rear chassis using the 6,000-ton Giga Press has allowed Tesla to cut manufacturing costs by up to 40% by replacing around 70 separate parts with 2 large castings and a structural battery pack. So it's no surprise that Tesla is looking to replicate this efficiency with its upcoming affordable vehicle platform. The new car is even smaller than the Model 3, with a design that features very short front and rear quarters and virtually no trunk space, making it an ideal candidate to test the idea of casting a single-piece rear chassis. But no matter how small the car is, the 6,000-ton press used for the Model Y isn't powerful enough to cast the entire chassis at once, as it can currently only cast the rear chassis. So Tesla used a larger gigacasting machine to produce this low-cost car called the Model Q. Not only does it allow for the entire chassis to be produced in one casting, but the Giga Press can also cast 5 chassis of this model in one casting.
The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. It's, in fact, the line will move so fast that actually people can't even get close to it.
When Elon Musk first mentioned the 50,000-ton Giga Press, the first question we asked wasn't, is it even possible, but rather, how big is it going to be? Where would such a massive machine even be placed? How long would it take to install? And how could it possibly cast 5 entire underbodies at once? Well, this is no ordinary machine. According to Elon Musk, the new production line using this machine will operate at a speed so fast that humans won't even be able to get near it. The entire process, from pouring molten metal to high-pressure casting, mold cooling, and part removal, will be handled entirely by robots and advanced automation. No workers standing nearby to inspect, no one manually adjusting parts. Everything will be synchronized in a fully closed loop system, where each press cycle takes only about 5 seconds. In other words, within just a few blinks of an eye, a complete one-piece EV frame will be finished and ready to move on to assembly. You can imagine that with a 50,000-ton Giga Press, it could easily be as large as a 3- or 4-story building laid on its side. Tesla may need to construct a dedicated facility just to house it, possibly with a specially reinforced concrete foundation several meters deep to support the immense weight. Compared to the existing machines like the 6,000-ton and 9,000-ton Giga Presses, this new machine delivers roughly 8.3 times and 5.5 times more pressing force, respectively. While the size, clamping force, and number of molds differ, the operating mechanism of the 50,000-ton Giga Press isn't fundamentally different from the 6,000 or 9,000-ton models. It all still starts with material preparation. Tesla melts down new aluminum ingots along with leftover aluminum from previous castings in a furnace heated to around 850 degrees Celsius or 1,562 degrees Fahrenheit. Then any surface impurities are removed before the molten metal is transferred through heated pipes into a sealed holding furnace, maintaining a temperature between 1,382 degrees Fahrenheit to 1,562 degrees Fahrenheit. From what we know, the Giga Press uses a dual furnace system to process the aluminum alloy. One furnace acts as the melting furnace, powered by natural gas and operating at around 1,562 degrees Fahrenheit. The other serves as a holding furnace, electrically heated and maintaining a temperature between 1,382 degrees Fahrenheit and 1,562 degrees Fahrenheit, as previously mentioned. Inside the holding furnace where the molten aluminum is stored, the empty space is filled with nitrogen gas. This is no coincidence. Nitrogen acts as an invisible protective layer, preventing the aluminum from coming into contact with outside air and thus avoiding oxidation. At the same time, it helps maintain a stable temperature, keeping the metal in a ready-to-cast state. But nitrogen alone isn't enough to achieve optimal casting quality. Tesla also uses argon gas in combination with a rotary degassing unit, a device that stirs the molten alloy and drives gas bubbles and impurities to the surface. After that, a specialized silicon carbide filter removes particles larger than 25 microns, ensuring the alloy is clean and uniform before it enters the mold. This is the material refinement stage, an extremely important step to ensure the quality of the final cast product. This is the material refinement stage, a critical step in ensuring the quality of the final cast product. Once the material is ready, the next step is mold preparation, and the Giga Press handles this with near-perfect precision. Before each casting cycle, a specialized robot sprays about 35 milliliters of soybean oil in a thin, even layer across the mold's surface. It's a bit like non-stick coating in cooking. This helps the cast parts release cleanly from the mold without warping or surface defects. Immediately afterward, the system creates a vacuum inside the mold cavity, removing any remaining air to ensure the molten aluminum fills the mold completely, without trapped gas or bubbles. Once everything is perfectly aligned, the molten aluminum is transferred from the holding furnace into the Giga Press's injection chamber. There, a high-speed piston injects the alloy into the mold at extremely high pressure. To ensure smooth operation, the piston itself is lubricated with about 8 milliliters of oil before each injection. Everything happens in just a matter of seconds, but every detail plays a crucial role in producing a one-piece EV frame with micrometer-level precision.
In a single casting machine, we could do like 5 at a time or something. I'm trying to think like how do you scale castings because you got liquid metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
When the molten aluminum is injected into the mold, solidification doesn't happen instantly. The alloy needs to remain inside the mold for a few seconds to begin the crystallization process. Once the material is solid enough, the entire underbody frame is ejected from the mold at a temperature of around 400 degrees Celsius or 752 degrees Fahrenheit, still extremely hot compared to ambient conditions. Immediately afterward, the cast part is transferred to a cooling bath, where the temperature rapidly drops to around 50 degrees Celsius or 122 degrees Fahrenheit in just a few dozen seconds. Rapid cooling isn't just about lowering the temperature, it also serves an important technical purpose, improving the alloy's crystal structure, eliminating defects formed during solidification, and enhancing the mechanical strength of the entire underbody frame.
So, we got to jam the liquid metal in, cool it down real fast, like real fast.
Meanwhile, the mold after releasing the cast part is cooled down to around 185 degrees Celsius or 365 degrees Fahrenheit, a temperature low enough to stabilize heat levels without affecting the next casting cycle. A specialized robotic system then thoroughly cleans the mold surface, removing any leftover material residue and excess lubricant. Thanks to the speed and precision of the entire system, a new casting cycle can begin just 1 to 2 minutes after the previous one ends. Any excess metal such as flash, runners, or leftover sprues is automatically trimmed and recycled back into the melting furnace for future cycles, ensuring virtually zero material waste. To make sure every product meets strict quality standards, an industrial X-ray imaging system is deployed directly on site. Each vehicle frame is scanned to detect microscopic defects, such as gas porosity or internal cracks, that can't be seen with the naked eye. This is a critical step in ensuring structural integrity, especially important since this cast frame serves as the primary load-bearing foundation of the entire vehicle. And finally, to withstand the immense pressure of injecting molten alloy at high speed, the Giga Press must maintain an extremely powerful clamping force to keep the mold tightly sealed, preventing cracks, warping, or leaks. With the 50,000-ton Giga Press, this clamping force ranks among the strongest ever used in the automotive industry. According to Elon Musk, achieving the incredible speed and precision of the 50,000-ton Giga Press required Tesla to develop a series of innovations never before seen in the auto industry. First is an ultra-fast cooling system, custom designed to rapidly cool massive cast components in record time without compromising the metal's structural integrity. Second is an intelligent mold release mechanism that allows parts to separate from the mold smoothly and precisely, with no manual intervention required. But the biggest breakthrough lies in the AI-integrated automated quality inspection system. From analyzing X-ray images to evaluating real-time data from thermal and pressure sensors, this system can detect potential flaws with high accuracy, completely eliminating the need for human visual checks. This represents a major leap forward compared to previous generations of gigapresses, such as those used for the Model Y and Cybertruck, which were already highly advanced, but still hadn't reached the deep, intelligent level of automation seen in the 50,000-ton Giga Press. More importantly, the fusion of robotics, artificial intelligence, and precision engineering has brought Tesla closer to a production model that closely resembles the electronics industry. Ultra-high speed, hyper-streamlined processes, factory floor space optimized down to the square meter, and near zero variation between repeated products. As we mentioned earlier, Tesla needs to replicate the efficiency of the Giga Press for the Model Q, and this compact hatchback is seen as the most ideal candidate for fully casting its underbody using the 50,000-ton Giga Press. The reason goes beyond just aiming for massive production volumes. It lies in the design philosophy and industrial strategy behind this vehicle. First and foremost, the Model Q is positioned as a global affordable EV, targeting the mass market with an estimated production volume of millions of units per year. At such a massive scale, streamlining the production line becomes a matter of survival. Casting the entire underbody in a single press cycle drastically shortens production time, reduces labor costs, minimizes the number of welding robots needed, and optimizes factory floor space, perfectly aligning with Elon Musk's matchbox manufacturing philosophy.
And that's actually kind of how they do it in like small volume castings. They'll have a casting block that'll make 100 Matchbox cars at a time. Maybe we just make that real big. Yeah, we have the Cathedral of Casting back there.
The Model Q features a compact and simple design, without the complex curves or multi-layered structures seen in the Model Y or Model 3. This structure is ideal for casting the entire underbody as a single piece in a short amount of time, what Musk described as just 5 seconds.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
It may sound like science fiction, but in reality, with an optimized structure like the Model Q, Tesla can completely press out the entire chassis in just one pressing cycle, lasting less than 5 seconds. Not counting the next assembly steps that are fully automated by AI robots, a line so fast that humans cannot get close. If this becomes a reality, Tesla is not only speeding up production, it is redefining the limits of global industrial manufacturing capabilities. While the EV market is booming with fierce competition from Chinese automakers and legacy brands, Tesla is quietly preparing to unveil a new trump card, an affordable model that could shake up the entire industry. Although it hasn't been officially announced, multiple sources suggest that this vehicle is in its final stages of development and could be introduced at any moment. Often referred to by the unofficial name Model 2, the car is expected to be priced around $25,000, a figure that both tech enthusiasts and consumers have been eagerly awaiting for years. But this isn't just about a cheap car. It could be the Tesla for the masses, opening the door to EV ownership for millions of people worldwide. If you're hoping for a completely new design from Tesla, you might want to adjust your expectations. This model will almost certainly share many design cues with the Model Y or Model 3, not due to a lack of creativity, but because of manufacturing feasibility. Developing a vehicle entirely from scratch is not only expensive, but also slows down the time it takes to bring the product to market. Tesla could leverage its existing production lines, interior components, and even battery packs that have been optimized over the years. This is a strategy long employed by automakers like Toyota, BMW, and Audi, sharing platforms across multiple models to cut costs and boost manufacturing efficiency. The result? Consumers benefit from better pricing without having to sacrifice much in terms of quality or performance. While Tesla was once the undisputed leader in technology and cool factor, Chinese EV makers like BYD, XPeng, and NIO are catching up fast, especially in the affordable segment. That's why launching a Tesla priced under $30,000 isn't just a market expansion strategy. It's a necessary counterattack. Some customers have even delayed buying a Model 3 or Model Y, hoping that the upcoming model will be more budget-friendly while still offering the hallmarks of a true Tesla: strong performance, advanced self-driving capabilities, and a superior software ecosystem. Despite the affordable label, the Model 2 is expected to be a real Tesla. That likely comes with a few trade-offs: a more minimal interior, fewer premium features, or a driving range that's not as impressive as the higher-end models. Still, with a true starting price around $25,000, it would be a steal in the EV world. When Elon Musk first hinted at plans for a low-cost Tesla, he wasn't just talking about a new model, he was talking about a strategic turning point. As predicted, the Model 2 will be a compact, streamlined, and smart hatchback. According to internal sources, it will be roughly 15% shorter and up to 30% lighter than the Model 3, with an estimated length under 157 inches. Put it next to competitors like the Toyota Yaris and you'll see. This is an EV designed for the city, ideal for small families, young drivers, or anyone tired of hunting for parking in urban areas. And to hit the almost unbelievable price point Tesla is aiming for, the Model 2 has shed many flashy features that aren't essential. No more alloy wheels, instead you'll get 17-inch steel rims. No more double-pane glass, just standard windows. And paint, only the basic color options. But you know what? None of these changes affect what really matters in a Tesla: efficiency, performance, and connectivity. The overall design of the Model 2 still carries Tesla's signature DNA. The slim LED headlight bar, a design element already seen on the Cybertruck, Cybercab, and Model Y, remains. This isn't just about aesthetics, it's a strategic move. Reusing proven designs helps cut development costs while maintaining a sense of brand cohesion and premium appeal. That's important because no one wants to drive something that feels cheap, and Tesla knows that. Step inside, and you'll immediately feel the minimalist spirit, still very much Tesla. The cabin is spacious enough for 5, but the seats are fabric instead of leather. There's no sunroof, no ambient lighting, and no heated seats. The sound system has just 7 speakers, compared to 13 in the Model Y. Some might say the interior feels bare, but in reality, everything has been purposefully stripped down to serve one goal: cost optimization, so that millions of people can afford an electric vehicle. If that doesn't sit well with you, buy a Model 3 or Model Y. The Model 2 isn't meant for you. That's the mindset Elon Musk is working with. Of course, Tesla's iconic central touchscreen is still there, though it may be smaller than the one in the Model 3 or Y, and it still controls everything: entertainment, climate, and vehicle settings. No extra buttons, no unnecessary complexity, just clean design that helps keep production costs as low as possible. What about performance? Don't expect this thing to launch like a Model S Plaid. But honestly, you won't need that kind of speed if your driving is mostly in the city. The Model 2 will likely come with a single rear-wheel drive motor, going from 0 to 60 miles per hour in about 7 seconds, with a top speed of 112 miles per hour. Sure, those numbers won't blow anyone away, but compared to a Toyota Corolla Cross or a Hyundai Kona, the Model 2 is still quicker, smoother, and way cheaper to run. What most people really care about, though, is range. Can a Model 3 or Model Y hit 300 miles? Absolutely. But at a sub-$25,000 price point, you can't have everything. We believe Tesla will go with a 40 or 50 kilowatt-hour battery pack, offering around 200 to 250 miles under ideal conditions, more than enough for most Americans' daily driving without the need for constant charging. Now, here's the real kicker from Tesla's Master Plan Part 3. Elon Musk confirmed something that may seem small but is actually a game changer. The Model 2 will use LFP batteries. And honestly, it's the smartest move they could make. Lithium iron phosphate is currently the cheapest battery tech on the market, costing around $55 per kilowatt hour. Thanks to Tesla's LFP plant in Nevada, supply no longer depends on China, a huge win that helps the company dodge import hurdles and tariffs. This opens the door for uninterrupted large-scale production, which has been a pain point in Tesla's past projects. With a 53 kilowatt-hour pack, the total battery cost comes in around $3,000, which is extremely impressive, especially when you factor in LFP's longer lifespan and better fire resistance compared to traditional lithium-ion batteries. Its ability to handle fast charging at high voltages, along with deep discharges without major wear, makes it a perfect fit for an affordable everyday EV. But that's not all. The Model 2 is also expected to retain Tesla's 400-volt electrical system, like the one in the Model Y. That means it can charge from 0 to 80% in about 25 minutes at a V4 supercharger pushing up to 250 kilowatts. In the budget EV segment, almost nothing else comes close. Even competitors like the Chevy Bolt or Nissan Leaf still lag way behind when it comes to fast charging speeds. While the Model 2 won't offer a long-range version, a move aimed at keeping the price under the key $25,000 psychological threshold, its lightweight build and sleek aerodynamic design should still deliver a solid 200 to 250 miles of range. That's more than enough for most daily urban commutes. Another big question is, will the Model 2 support full self-driving? The answer is yes, but with a more flexible approach. Every Tesla built since 2019 already comes with the full suite of FSD hardware, including cameras, radar, ultrasonic sensors, and Tesla's custom-built processing chip. The Model 2 will be no exception. However, to actually unlock FSD features, customers will need to pay an extra $8,000 or opt for a monthly subscription. It's a smart move. Bundling FSD by default would raise the car's base price, which goes against Tesla's mission to make EVs more accessible. But by offering it as an optional add-on, with the hardware already in place, buyers can choose to upgrade later if and when they actually need it. Even more exciting, Tesla just unveiled its robotaxi network last month, which significantly raises the stakes for the Model 2. In the future, if owners can enroll their Model 2 in the self-driving robotaxi fleet, the car could become a passive income generator, a huge advantage over other low-cost EVs that are only used for personal transport. That said, we'll be honest, the cost of FSD is still a major hurdle for many Model 2 buyers, especially those more concerned with keeping ownership costs low than having cutting-edge tech. But in a few years, once the software matures and pricing drops, early Model 2 owners will be ahead of the curve, sitting on a platform already primed for full automation. As we've mentioned before, hitting that $25,000 starting price wasn't going to happen by building a brand new factory from scratch. Instead, Tesla is leveraging existing infrastructure. The Model 3 and Model Y production lines in Fremont and Giga Shanghai are the key. In fact, Model 2 prototypes have already been spotted testing around the Fremont factory, a strong sign this will be the launchpad for mass production. Fremont is already home to an advanced gigacasting line used for Model Y, so it makes perfect sense to expand production there. One of the biggest breakthroughs is a new Giga Press, even more powerful than the 6,000-ton press used for the Model Y. This upgraded machine can cast the entire rear underbody in one shot, or even multiple frames at once. That reduces part count, boosts chassis strength, cuts down assembly errors, and most importantly, lowers the cost per unit. This is critical if Tesla hopes to meet massive demand while keeping prices competitive. But to actually get the Model 2 into the hands of everyday American drivers, the $7,500 federal tax credit will likely make or break it. We believe Tesla has strategically designed the Model 2 to look like a $25,000 car, but in reality, that price only becomes possible after the tax credit is applied. In fact, Tesla has started marketing the incentive as a direct discount, making the Model 2 even more appealing compared to gas-powered cars in the same class. That said, Government policy isn't always reliable. Some analysts believe EV incentives could expire as early as 2026, especially if a new administration shifts its budget priorities or rolls back environmental subsidies. And let's be honest, the current relationship between Elon Musk and Donald Trump is unpredictable at best, adding even more uncertainty to the future of these incentives. If the $7,500 tax credit disappears, Tesla will be faced with a tough choice. Either lower the sticker price by that amount, which is nearly impossible under current cost constraints, or raise the price of the Model 2, potentially losing its competitive edge in the affordable EV segment. Either path puts pressure on Tesla's already slim margins, something the company has always managed very carefully in past products. From a consumer perspective, some skeptics argue that Americans may not be that excited about a small, minimalist hatchback like the Model 2. But the data says otherwise. Compact cars like the Toyota Corolla, Honda Civic, and Mazda 3 still enjoy steady sales, especially in urban areas. On top of that, Tesla's unbeatable strengths, from a powerful brand image and a seamless software ecosystem to a vast supercharger network, make the Model 2 an incredibly smart choice. Still, managing expectations will be a major challenge. Many buyers associate Tesla with a premium experience, like the spacious Model Y or the high-tech Model S. So when they step inside a more stripped-down Model 2, they might be disappointed. There won't be a panoramic sunroof, leather seats, or a premium sound system. That's why Tesla needs to be upfront. The Model 2 isn't a budget version of the Model Y. It's an entirely new vision for a smart, efficient, and connected electric vehicle for the masses. And the pressure is only growing. Chinese competitors like BYD are already shaking up the market, with the Dolphin selling in China for just $13,865, a price point that's almost unthinkable. To compete with this wave, Tesla has to prove that the Model 2 isn't just cheap, it's worth every penny, delivering better performance, a richer user experience, and seamless integration into the ever-expanding Tesla ecosystem. Moving on to the Tesla bot news. Rumors that the Tesla bot is in disarray or being killed are completely false. These rumors come after reports that Tesla has temporarily halted parts orders for Optimus, leading some unofficial sources and netizens to jump to the conclusion that Tesla's humanoid robot project is going downhill or in serious crisis. The Tesla Optimus project has not been canceled, despite widespread speculation. Production is simply on pause for at least 2 months, a necessary break to upgrade its design and hardware in preparation for a major leap forward. Optimus Gen 3. This is not a hasty decision. Elon Musk has repeatedly stated on X, formerly Twitter, that Optimus 5.3 will truly blow people's minds, and that a lot of improvements are being integrated into the next design. In China, 2 major component suppliers confirmed that Tesla hasn't canceled orders, but merely delayed shipments until the new design is finalized. According to internal sources, Tesla has already purchased enough parts to assemble around 1,200 Optimus units, with nearly 1,000 robots already completed. However, with the halt in new parts procurement, the goal of producing 5,000 robots in 2025, as Musk mentioned during an all-hands meeting, is now at risk of delay. A major leadership change has also taken place within the Optimus team. Milan Kovac has stepped down as project lead and has been replaced by Ashok Elaswamy, Tesla's VP of AI. This marks a pivotal moment. Ashok is known for his practical engineering mindset and strong product direction. His leadership in the redesign phase signals Tesla's transition from idea testing to optimizing for large-scale manufacturing. From a technical perspective, Optimus Gen 2 has made significant progress but still faces several limitations. Internal reports cite issues such as joint motors overheating, low payload capacity in the robotic arms, short actuator lifespan, and limited battery capacity. Tesla is now testing hardware solutions from at least 3 different suppliers to improve durability and performance. These upgrades are intended not only for factory use, but also to lay the groundwork for Optimus to eventually operate in consumer environments. Currently, Optimus is being used in a limited capacity, moving battery packs on Tesla's battery production line. its productivity still lags behind that of an average human worker, and it hasn't been assigned any complex assembly tasks yet. This shows the technology still has a long way to go before it fulfills Musk's vision of becoming a replacement worker or household assistant. Still, Musk's vision remains unchanged. He has described Optimus as a robotic companion capable of cleaning homes, babysitting, walking dogs, teaching, and even participating in manufacturing and service industries. Under the current roadmap, Tesla plans to begin deploying Optimus outside of factory settings in the second half of 2026, starting with internal employees. This is a smart strategy. Roll it out in a friendly, controlled environment, collect real-world feedback, and avoid unnecessary legal or PR risks. This pause in production should not be seen as a negative sign. In Tesla's case, it's a strategic retreat to prepare for a much bigger leap. Rather than rushing an unfinished product to market, a mistake many robotics companies are making, Tesla is taking the time to refine and optimize the design with a clear end goal: to turn Optimus into a mass-market consumer product, present in millions of homes around the world. We are still in the early stages of the humanoid robotics race, but given how far Tesla has come in just a few short years, from a rough prototype to a Gen 2 robot performing real tasks in a factory, there's no denying they're leading the game. If Optimus Gen 3 lives up to expectations, with improved durability, better motion capabilities, and a lower cost, it could mark a turning point not just for Tesla, but for the entire global robotics industry. And on that day, today's skepticism may be remembered as just a small footprint on the long journey Elon Musk calls a future where humans are freed from manual labor. We truly believe that Elon Musk could be seen as something of a magician. He has the ability to dazzle the entire world today, only for everyone to potentially find themselves swept into a whirlwind of disappointment the next day. Over time, the Tesla CEO has thrilled the public with rapid advancements in a short period through Tesla Optimus, delivering impressive and polished demo videos that have garnered plenty of praise for the engineering Tesla has brought to this robot. Combined with bold statements such as a $20,000 price tag and a target release for customers in 2026, this has made the entire tech world watch its every move closely, as nearly everyone wants to own a home assistant robot. However, recent confirmed news reveals that things are coming to a halt for the Tesla bot. The company will pause production of this humanoid robot for several reasons. Of course, this doesn't mean it's being canceled entirely. Definitely not. And here's why Tesla is temporarily halting production of the Tesla bot. Okay, when the reports on this issue came out, much of the discussion centered on whether Tesla might be just like many other robotics companies, able to develop a few prototypes, but struggling when it comes to mass production. Some even said Elon Musk might as well crown himself the world's greatest hype man, having turned Tesla into a company now better known for delays, broken promises, and unreliability. However, the situation might not be that extreme, as the Tesla bot hasn't been permanently canceled, just temporarily paused. Yeah, according to reliable reports, Tesla will suspend the production of Optimus for at least 2 months. The main reason for the pause is that Optimus needs a design revision and several hardware upgrades in preparation for the launch of its final version, Optimus Gen 3. This aligns with Elon Musk's earlier statements on X, where he said, "So many improvements to come in the next design of Optimus, and Optimus Viv 3 going to be wow." According to reports from China, Tesla stopped ordering components for the robot about 2 weeks ago. 2 of Tesla's component suppliers from China confirmed that Tesla has not canceled its orders entirely. Instead, the company plans to resume purchasing once the redesign is complete. The redesign process is expected to take around 2 months. As of the end of May, Tesla had already procured enough components to build 1,200 Optimus units and had assembled nearly 1,000 of them. Previously, during Tesla's all-hands meeting, Elon Musk had promised to manufacture 5,000 units this year. With the pause in component orders, both sources believe that this production goal is now unlikely to be met.
So this year, we hopefully will be able to make about 5,000 Optimus robots. We're aiming for enough parts to make 10,000, maybe 12,000. But since it's a totally new product with totally new, like everything is totally new, I'll say like we're succeeding if we get to half of the 10th.
This adjustment began in early June when Milan Kovac, the head of the Optimus project, stepped down for personal reasons. Shortly after, Tesla's VP of AI software, Ashok Elaswamy, took over the Optimus project. He wanted to improve the design before ramping up production. The new design of Optimus is said to be quite unique and more suitable for mass production compared to the current version. Of course, even in its current form, Optimus Gen 2 still outperforms most humanoid robot designs available globally. However, reports indicate that the redesign isn't the only reason production has been paused. According to Tesla's communication with suppliers, Optimus is still facing several hardware issues: overheating joint motors, low payload capacity for dexterous hands, short transmission lifespan, and limited battery life. Tesla is still testing samples from multiple dexterous hand suppliers and is currently exploring at least 3 different technical approaches. An insider at Tesla revealed that, for now, Optimus is only moving batteries around inside Tesla's battery factories, and even then, its efficiency is less than half that of a human worker. It still hasn't been assigned any of the more complex vehicle assembly tasks. It's clear that Tesla still needs more time to optimize Optimus. There's still a long road ahead before it's truly ready to become a homemaker robot. However, Elon Musk's repeated bold claims have led many people to believe that these breakthroughs are just around the corner.
You can imagine like your own personal robot buddy that is a great friend, but also takes care of your house. We'll clean your house, we'll mow the lawn, we'll walk the dog, we'll teach your kids, we'll babysit, and we'll also enable the production of goods and services. I'm hopefully ready for Optimus to be used outside of Tesla-controlled environment, or maybe around the middle of next year, second half of next year sometime. So that's, I think, yeah, sounds about right. Probably second half of next year is when they'll be available. And then we will offer Optimus robots first to Tesla employees.
Yeah, it sounds cool. It's exciting, right? But until Optimus becomes our companion, it needs to go through a series of upgrades, especially the Gen 3 version. We want to reiterate a big upgrade in the upcoming version. Besides the design, you can skip this part if you've heard us talk about it in previous episodes. The first feature we believe will get most people truly excited is that the next version of Optimus will be integrated with Grok Voice AI, a proprietary voice control system that Elon Musk has officially confirmed. Most humanoid robots today don't come equipped with voice functionality, mainly because it requires complex and advanced engineering. And even when they do, it's usually just a few pre-programmed phrases for basic communication. That's honestly pretty boring. Grok Voice takes Optimus far beyond the image of a machine that just gets tasks done, transforming it into an intelligent companion capable of conversation, explanations, and human-like responses. What sets Grok Voice apart is that it isn't limited by fixed commands, like traditional virtual assistants. Built on advanced AI technology from xAI, Grok enables Optimus to understand your speech in context, respond naturally, and even communicate like a real person. This is especially helpful for people who aren't tech-savvy, like the elderly or children. Instead of learning how to use a device, now you can simply say, "Optimus, show me how to start the washing machine," and the robot will patiently walk you through each step. From the very beginning, Elon Musk emphasized that Tesla Optimus isn't just an industrial robot. It's meant to be an assistant in everyday life. With Grok Voice, that vision is becoming even more tangible. Whether it's helping children study and answering questions, like a personal tutor, assisting the elderly with using household appliances, or simply finding information, Optimus is now capable of serving a wide range of purposes in a flexible, accessible, and incredibly user-friendly way. And it doesn't stop there. Another major strength of Grok Voice is its ability to function effectively in a variety of environments, even in loud or multilingual settings. While most robots today only perform well under ideal conditions, Optimus can filter out background noise, accurately identify who's speaking, and follow voice commands without being thrown off by music or industrial noise. This was proven at the We Robot event last October, where 50 Optimus units operated simultaneously in a crowded, noisy space. Despite the chaos, they responded accurately and left a strong impression on attendees with their performance. Reports from China also revealed that Tesla has been developing its humanoid robot hardware with hundreds of supply chain partners over the past 3 years, building a fully integrated humanoid robot supply chain. By the end of last year, the Optimus R&D team had grown to over 400 members. With an estimated cost of around $60,000 per unit, Tesla's component spending on Optimus alone is expected to exceed $300 million this year. Elon Musk has truly invested heavily in Optimus, so walking away from the project is simply not on the table. Beyond Grok Voice, the Gen 3 version of Optimus is being equipped with a completely redesigned hand module featuring 22 degrees of freedom, double the 11 found in the previous version. But this isn't just a numerical upgrade in joint count. What Tesla is aiming for is a complete redefinition of what a robotic hand can do, transforming it from a basic imitation limb into a highly sophisticated manipulation tool capable of handling human-level tasks, whether in the kitchen or on the factory floor. There are no more exposed wires or visible actuators. Everything in the new hand has been redesigned with high-level shielding and a minimalistic aesthetic, to the point where it almost looks like a gloved human hand. But it's not just about looks. It's built for a very clear purpose: real-world performance. Water, dust, impacts. The new hand can handle it all without fear of short circuits or actuator failure. With this version, the arm of Optimus is no longer a lab-only demo piece. It's a functional tool, ready for tasks that demand a high level of precision and durability.
The new Optimus 22 degree of freedom hand and forearm is now in production. And it's learning to walk and catch balls. It's pretty cool. I mean, look, that's where we came from. It's wild. So in a very short period of time, Optimus has gone from being an idea to the most sophisticated humanoid robot on Earth.
Yeah.
The hand might be close to half of all the engineering in Optimus. From an electromechanical standpoint, the hand is probably roughly half of the engineering.
So much the intelligence of humans goes into what we do with our hands.
Yeah.
Like the manipulation of the world, manipulation of objects in the world.
In internal testing, Optimus has already performed tasks that were previously considered doable only by humans. Folding clothes, taking out the trash, using an iron, pulling curtain. These may seem like basic chores, but they were all done with the previous 11 degree of freedom hands. With double the precision in Gen 3, Optimus's new hands are sure to produce some truly jaw-dropping demo videos soon. Those 22 degrees of freedom aren't just a flashy number for marketing materials. They're the result of a series of mechanical breakthroughs, including ultra-compact actuators relocated to the forearm instead of the hand, allowing for real-time force feedback control, and, most importantly, hand-eye coordination enabled by a vision-based system. All of this comes down to one simple principle. If you want a robot to replace humans in real tasks, it needs to have hands that work almost like a human's.
If you want to have a humanoid robot that can do things that a human can do, it's a very high bar. So our new arm has 22 degrees of freedom instead of 11.
And that's exactly what's happening with Optimus Gen 3. It's no longer just a showpiece. It's evolving to manipulate the world as we do every day, and its hands are the clearest proof of that. Improved movement speed is also an upgrade being applied to the Generation 3 version. Not just a side feature, but a core part of the ambition to make Optimus a robot that can work like a human, in the real world, with real life. From the early days of staggering and being compared to a drunkard, the recent minor upgrades show that Optimus has made significant progress. Each step becomes more stable, the frequency of swaying is significantly reduced, and the body posture is also more naturally aligned. However, those upgrades are not really significant. It is still very difficult to convince. So Tesla is making changes at the hardware level to synchronize the hip and knee actuators, and especially the real-time reflex processing algorithm. Although Optimus currently moves at only around 2.2 miles per hour slower than some competitors like Atlas or Unitree, what stands out is Tesla's clear direction. prioritizing safety, balance with minimal falls, then natural movement, and only afterward, focusing on speed. It's a logical progression when you're not building robots for show, but for working alongside humans in warehouses, offices, or homes. One interesting detail that often goes unnoticed and which many people initially mocked is Optimus' bent knee posture. In reality, it's a deliberate control strategy. Bending the knees lowers the center of gravity, increasing overall stability, especially on uneven ground. Tesla leverages this posture to help the robot self-balance without relying heavily on active stabilization systems. This not only saves energy, but also improves reliability. What we're seeing today is just the tip of the iceberg. In the most recent firmware update, Tesla began testing a feature called step anticipation, predicting the next foot placement based on real-time sensor data, similar to how humans walk without needing to look at their feet. This marks a major step toward a new phase for Optimus, walking like a human, not just mimicking human movement. Among the transformative upgrades in Tesla's Optimus Gen 3, the most critical and revolutionary is its advanced AI real brain, as Elon Musk describes it. This neural network, powered by Tesla's cutting-edge AI-5 hardware, elevates Optimus beyond a mere humanoid robot into a versatile, autonomous entity capable of reshaping industries and daily life. Unlike its predecessors, which relied heavily on teleoperation and pre-programmed tasks, the Gen 3's brain leverages an end-to-end neural network inspired by Tesla's full self-driving system, enabling real-time decision-making, rapid learning, and unparalleled adaptability. This is not just an incremental improvement, it's the cornerstone that makes Optimus a potential game-changer in robotics. The real brain allows Optimus to process data from an array of sensors, cameras, and navigation systems, creating a dynamic understanding of its environment. It can learn up to 100 new tasks daily by analyzing human videos, from first-person perspectives to internet footage, mastering complex activities like cooking, cleaning, or assembling factory parts. This learning is exponential, as skills acquired by one Optimus unit are instantly shared across Tesla's cloud-based collaborative system, building a vast skill library at a pace no human workforce could match. For instance, if one robot learns to fold laundry, every Optimus worldwide can replicate it immediately, showcasing the power of this interconnected AI. What sets this brain apart is its ability to operate autonomously in unpredictable settings. Using 2D cameras and cloud-stored visual features, Optimus navigates unfamiliar spaces, avoids obstacles, and maintains balance on uneven terrain, even without visual input. Its processing speed, backed by 700 to 800 watts of computational power, supports complex two-handed tasks and real-time environmental analysis, reducing reliance on remote control. Those are the upgrades that will be available on the upcoming Gen 3 version, and one of the earlier supply chain sources added that Tesla could debut the Optimus Gen 3 at this year's shareholder meeting. Tesla's decision to suspend production of the Tesla Bot, or Optimus, may have left customers confused and questioning the future of the ambitious project. Is Tesla simply repeating the mistakes of many other robotics companies? Brilliant prototypes but falling apart when it comes to actual production? Or as some experts quip, Elon Musk deserves to be called the world's most hype man? The sudden hiatus is likely to make fans and investors worry about whether Optimus can live up to the expectations Elon Musk has set, especially since the robot is considered a breakthrough in artificial intelligence and automation. However, this is just a temporary phase, reflecting Tesla's commitment to perfecting Optimus Gen 3 with outstanding upgrades, such as a real brain AI brain, 22 degree of freedom arms, and optimized manufacturing design. This research and development process takes time to ensure quality and performance, especially as Tesla aims to deploy thousands of robots by 2025 and mass production by 2026. The pause is not the end, but a stepping stone for Optimus to come back stronger, ready to shape the future of labor and human-machine interaction. Customers can rest assured it is reassuring that Tesla is working hard to deliver a truly revolutionary product.